As we get into today's lesson, you need to know today's lesson is about something that's the difference between $20,000 a year, and it really is. And that is the difference between somebody who can write computer programs, which, by the way, computers speak math, and somebody who just runs software through a computer to get all the viruses out, you know? They're very different things. You'll find out one is called an IT, which usually has to do with somebody who fixes all the technical issues with computers inside the company. But a computer programmer is the person who's writing all of the math behind it. And that's worth a lot of money. But what's even more exciting is, after today, you're going to see you're fully capable of this. I mean, after Algebra 2, you've got a lot of skills as far as writing equations goes, polynomials go. And so it's a good start on that. So today is going to be about objective of writing a polynomial function from its zeros. And it's also going to be about putting that together with what do we want to see on the screen and how can we make that happen. And it's actually not a very difficult process. It's just not. So the expression x minus a is a factor of a polynomial. And we know that. That's what they've had us doing in the homework you just asked about from yesterday. We're finding factors. That's what we're doing. If and only if the value a is a zero of the related polynomial function. So here's what they're getting at. We do our factoring and it looks like that. X minus a. Well, if we said we want a zero, we would solve it. It would look really weird because it's all variables and a zero. But we'd say, okay, if I want x all by itself, I'm going to have to add a to both sides. So x is going to equal a. Now it makes sense because that's the zero. That's the number that we need. If it was x minus 3, we said the zero is 3 because 3 minus 3 is 0. So that's how it works. If it's x minus a is a 0. So when we get down here to writing a polynomial function from its zeros, it's just a matter of thinking backwards. That's all it is. It says, what is a cubic polynomial function in standard form with zeros -2, 2, and 3? All right? That's important. It tells me I can't use y. I'm going to have to use f of x. F of x, g of x, h of x, whatever you want. But that tells us, hey, this is a function. So now, how did they get a -2 for the 0? Well, it had to be x plus 2. Because when you put -2 plus 2 in there, it's 0. So how did they get it 2? Well, that must have been x minus 2. Thinking about that x minus a formula. And then the 3 came from x minus 3. Now we're not done, but that's a really powerful first step. Because what we've done is we've made sure that that's where this graph is going to cross the x-axis. That's where its zeros are, its x-intercepts. So now I look at this and I think, okay, they said they want this in standard polynomial form. That is not standard form. We know that. So there's a lot of multiplication to be done here. If there's one that would be faster and easier to group together, then that's the math I would want to do first. And that's right here. That is called the sum and difference pattern. We have a +2 and a -2. And we look at it and we realize, hey, if we FOIL that, that's not going to have a little term. Of course we do that first. Those two are going to make this easier. So we'll have f of x equals x squared minus 2x plus 2x, dropping out. Slave, pay attention. Last times last, -4. Not done. I have to have a polynomial function in standard form. But that's going to save me a lot of time because now I can just do FOIL on this and I'll have the answer. So f of x equals first times first. A couple of people have asked about this on the worksheet. They're like, what happens when you take something like this times itself over there? You add the exponents. So x squared times x to the first is x to the third. Outside times outside, -3x squared. Inside times inside, -4x. Last times last, plus 12. We just developed a polynomial. We wrote one. And you know, more than that, we can guarantee that this is going to cross at -2, 2, and 3. And whoever asked us for this, it might be in architecture. They might be asking you to create an arch for something. You see those quite a bit more nowadays. It used to be most architecture was really boxy, but they've really done a good job of starting to use a lot of curves on things. So I just wanted to show you this is going to do what we said it was going to do. It should cross at -2, 2, and 3. And it does. And there it is. So somebody tells us, I want it to look like this. We make it look like this. Computers speak math. This is what you put into the computer to see that. So that's what we want to do. So down here, we're getting a higher power this time. This one was a cubic. This one says, what is a quartic polynomial function in standard form? With, now of course we have 4 zeros because it's a quartic. I'm going to call this one g of x, just because I don't want to do all f of x all the time. You could call it f of x. It's not going to make any difference. But what I have to do here is figure out what happens with the -2, the -2, the 2, and the 3. And we think backwards. Where did they come from? Where did -2 come from? X plus 2. Well, we're going to need that one twice. Where did 2 come from? X minus 2. Where did the 3 come from? X minus 3. That's a lot of factors. So there's going to be a lot of multiplication. Again, we want to group smartly. So what should be the first set we should work with? X plus 2 and x minus 2, exactly. So I think I'm going to go ahead and do that and move that out front. Because that's going to be x squared minus 4. Now it's kind of a toss-up. Although I do have something that I'm looking for here and thinking this would make it easier. Because people tend to make mistakes by starting to multiply by something that already has a power. Generally, you'll make less mistakes if you just do what you know, which is just normal FOIL first. So the first one's going to stay there. We're not going to do anything with it. But now the back one, we FOIL. First times first is x squared. Outside times outside is -3x. Inside times inside is plus 2x. So -3 plus 2 would be -1x minus 6. Now you can do that in 2 steps if you want to. You can write them all out and then simplify, and you'll get to the same place in the end. So now, what are we supposed to do with that? Well, we have to multiply it. And this is one of those things where, you know, we talk for a long time with the students, how can you help somebody remember how to do this? And I did my diagram and a student said, tell them clamshell. We're taking x squared times x squared times -x and times -6, and then -4 times x squared times -x and times -6. You make a clamshell. What you do? You just make sure that everything in the first parentheses gets multiplied by everything in the second parentheses. So g of x is going to equal x to the 4th minus x cubed minus 6x squared, and then go to the bottom of the clamshell, minus 4x squared plus 4x plus 24. And then, of course, we're going to simplify anything we can. Unfortunately, there's not a lot we can put together here. We got a couple of squareds, but the rest of it's going to stay just as it is. But again, I would want to punch this in and see, does this do what it's supposed to do? You know, we've got zeros at -2, -2, 2, and 3. So let's see. This one was x to the 4th minus x to the 3rd minus 10x squared plus 4x plus 24. Zoom 6. Wait a minute. Maybe we made a mistake. Wasn't it supposed to cross at -2? It's not. I want you to look up here and think logically. What about the -2 should tell us that something different's happening this time? There's two of them. There's two of them. It turns out that when you have two zeros, an even number, your graph bounces at that spot. It's called a tangent. It bounces off. If you only have it there once, or 3 times, or 5 times, an odd number of times, then your graph goes through. So we didn't do anything wrong. That's exactly what was supposed to happen. We told it. Put the -2 up there twice. It's like it hits it and it bounces off and it gets to count as 2. So down here they wanted us to graph them. And we start by saying, okay, they just told us the zeros were -2, 2, and 3. And we're just going to do a sketch. We're not going to get nitpicky. I know some of you don't have calculators at this point. That's okay. All you have to do is kind of make that. So this one bounced. And it went way up here somewhere and started coming back down. About like that. So that's the one that had the repeat 0 at -2. The other one was zeros at -2, 2, and 3. So same zeros. But that one was a cubic. Let me put that one up here again so you can see it. That one was x to the third minus 3x squared minus 4x plus 12. And I'll turn this graph off. So we just see that one. All right, so doing this, then up to where we can't see it, but eventually it comes back down and it's going down just a little bit and back up. Now hopefully as we're doing that, you're thinking to yourself, I knew that was going to do that. Because here's what we know. We knew this one was a cubic. This has to be its end behavior. They told us where the zeros were going to be. We know what it has to do. It has to go up, it has to come down, and then go back through that point. And now, thanks to the fact that we had a -2 twice on this one, we now know if anything's there twice, it's going to be a bouncer. So we can get a lot of what we need for our formula just by making a little visual. This is what I want to happen as I go through it. All right, so we're not done with writing them. However, because we changed the test, because we didn't get as far as we thought we would before the holiday break this time, we put the test on 5.1 and 5.2. But on your test, we have to put these on there. We're still writing them, but here's the deal. They're not in your packet. So I checked your packet. You should have plenty of room on the bottom of page 7 and on the bottom of page 10. There'll be spare room there. So maybe put one of them on the bottom of page 7, and then when you get to the second one, put that on the bottom of page 10. But go ahead and write it down, because like I said, it's important for that 4-letter word test that you're going to have. So write a polynomial function in standard form with zeros 3i and square root of 2. So bottom of page 7, bottom of page 10, as long as you don't write huge. You should have some spare space there. You don't find someplace in your packet. If that drives you bonkers, you can always grab some notebook. Just the top one for now, please, so that we're not reading. Right, polynomial function in standard form with zeros, 3i, and square root of 2. Hey, no fear, they didn't tell us if it's a cubic, a quartic, a quintic, what is it? Because we're supposed to know. You're not supposed to need that from it. Here's why. If it only has 2 zeros, it's supposed to be a quadratic. But this doesn't only have 2 zeros. Because here's what we know. Imaginaries never come alone. Imaginaries always come in pairs. Because in the quadratic formula, remember, it's plus or minus the square root of. So if 3i is a 0, so is negative 3i. And we need to make sure we don't miss that one. Same thing for radicals. Plus or minus square root of. If square root of 2 is there, we have to know the negative square root of 2 is there. They're not going to tell us that. They're saying, you should know that. They always come in pairs. So that's the first thing we need up here. All imaginary and radicals. It's hard for me to write up that high. Occur in pairs. And they're not going to give us both. They're just not. Let's say here's one. Now go on your merry way. So we have to know if you see imaginary, positive and negative are both there. If you see square roots, positive and negative are both there. So when we write our f of x, this is going to look pretty weird. X minus 3i, x plus 3i, x minus the square root of 2, and x plus the square root of 2. Oh, that just looks exhausting. It's actually easier than what we just did. If you group these together right, they get easier immediately. Now, if you're looking at that thinking, well, how do I know how to group this? You know how to group it. Because remember, if we take I times I, we're going to get this I squared, which is the square root of negative 1. So we're going to go ahead, or I should say negative 1. We're going to go ahead and group these two together and these two together. And magic will happen. And we will end up with something pretty decent to work with. So f of x equals, all right, well, let's see here. First times first is x squared. Outside times outside is plus 3ix, but inside times inside is minus 3ix. So I'm not even going to write that down. Last times last is minus 9i squared. But wait a minute. We're supposed to know what I squared is. It's negative 1. So we say to ourselves, self, I'm getting that I out of there. I'm going to give it the boot. Negative 9 times negative 1 is positive 9. It just got the boot. X minus the square root of 2 and x plus the square root of 2. Hey, that's that sum and difference pattern again. Let's see here. First times first is x squared. Outside times outside plus square root of 2x, but inside times inside is minus square root of 2x. Last times last, negative and positive is negative square root of 4. Wait a minute. We know what the square root of 4 is. What's the square root of 4? It's 2. Oh, look at that. If we group them the right way, all we have to do is FOIL. That's it, and we'll be done. So grouping is incredibly important with these. F of x equals x to the 4th. Let's see, we've got, well, I'll write it all out. Minus 2x squared plus 9x squared minus 18, and then we just simplify a little bit. But I have bad news. We can't check this on the graphing calculator. How come? We could check the other ones that we did. Why can't we check this? What does I mean? Imaginary. They're made up. We won't see them. We won't see them. So we have to make sure we do the math slowly and carefully when we want imaginary zeros, when we don't want our zeros to show up. So we'd see the square root of 2 and the negative square root of 2, but we would not see the other two zeros. They just would not be there. All right, this one is write a polynomial function in standard form with zeros 2i and square root of 5. Like I said, if you put that one on page 7, put the other one on page 10. We need to do this again. Make sure we're going to know what we're doing when we take this test. Write a polynomial function in standard form with zeros 2i and square root of 5. Again, they're not telling us. It's a quartic, it's a cubic, it's a whatever. We are supposed to know. What's the first thing you do? Take a peek back. What's step number 1? Yep. If the positives are there, then the negatives are there. So negative 2i and negative square root of 5. Now we have them all. And now we know there's 4, and this better be a quartic when we're done. So f of x equals x minus 2i, x plus 2i, x minus the square root of 5, and x plus the square root of 5. Ooh, scary. But not if you group it right. How are we going to group it? Put the two imaginaries together, put the two radicals together. Makes our life much easier. Imaginaries, radicals. So f of x equals x squared plus 2ix minus 2ix. Gone. Last times last, minus 4i squared. Ding, 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 bell go off in your head, and you go, wait a minute, that's negative 1. And negative 4 times negative 1 is positive 4. Simplify that one a lot. All right, the back 2. I want you to go ahead and do the multiplication and tell me what to put in there in simplified form. What you putting in that second set of parentheses? X squared minus 5. Because when you do your math up here, you've got x squared, and then it'll be minus the square root of 25, but we know that's 5. FOIL time. Half of x equals x to the 4th minus 5x squared plus 4x minus 20. And a little bit of combining like, oops, forgot my little squared there. Combining like terms. And we're done. Why can't we check this on the graphing calculator? Imaginaries. We're not going to see them. We're not. So now, we're going to take this a step further, and we're going to say, hey, we've got these all written. Don't we now know even more about how to graph them? Because we absolutely do. So being able to work forwards and backwards. Oh, I'm actually going to skip this one. Yeah, I'm going to skip this one. But let me stop right now and ask. I'm writing them. I mean, we just did the hardest writing ones you're going to do. 4, 3, 2, 1, 0 me on how you feel about writing the polynomials, doing all that multiplication and good stuff. That's better numbers than second hour. Good, you guys are confident. Love it. So what we're going to do next is we're going to say, we're going to be the computer programmer. How do we make that happen? How do we make stuff bounce? How do we make it cut through? How do we make that work? It's as easy as knowing that odd cuts through and even bounces for powers. That's it. So problem 3, when we wrote it out, looked like this. But if we went back and did g of x again, you'd see, wait a minute, x plus 2, it's there twice. It has a power of 2. That's even. That's a bouncer. So it's going to bounce off of negative 2. Now, it's called a repeat zero, but the fancy word for that is multiplicity. So if it's a repeat zero, it has multiplicity. Because negative 2 occurs twice, you can say that negative 2 is a zero of multiplicity 2, and we just write it like this. Negative 2 multiplicity 2. We just use that little lowercase m. Because, you know, it's math, and we're not going to see everybody's different spellings of multiplicity. Although it's a fun word to say, it's not a really fun word to spell. Multiplicity. A zero of multiplicity n means that x minus a appears as a factor n times. So it's like putting a little n up there and saying, what is that power? If that power is even, it's a bouncer. It's tangent at that point. If it's odd, it's going to cut through. Now, your book makes it sound much more difficult than that, so I'm going to explain their thing here. It says if a is a zero of multiplicity n in the polynomial function y equals p of x, then the behavior of the graph at the x-intercept a will be close to linear if n equals 1. Well, linear is a straight line. It's going to cut. And close to quadratic if n equals 2. Parabolas bounce. That's what they do. Close to cubic if n equals 3. Cubics, there are S-curves, but they're going to slice. They might have a little wave to them, but they're going to slice. So instead of all of this blah, blah, blah that they do here, let's do it this way. So multiplicity, if is odd. So if your power that you see is odd, that means your graph is going to cross at that spot, whatever that zero is. If it's even, it's going to be a bouncer. So it's going to bounce, and our fancy math word for that is tangent. So it'll be tangent at that point. So now, we will know n behavior. We will know where the zeros are, and we are going to know how the graph behaves at those zeros. We know just about everything there is to know about a graph, just by looking at the fabulous little equation that we have. So look at that bugger. Oh my! All right, first thing you want to know is the zeros. Where's this thing going to go? So is there a greatest common factor? Or we could pull out all of these. X squared, yeah, let's pull it out of there. Is that a perfect square trinomial there? No. Negative 8, not a perfect square. Doesn't mean we can't factor it, it just means there's nothing special about it. So good old-fashioned factoring, we need two numbers that multiply to negative 8 and add to negative 2. What are they? Negative 4 and positive 2. Now, we can find the zeros and whether or not they bounce or they cross. So let's see. Anywhere there's an x, there's an answer. There's a 0. What's the answer for that one? 0. Multiplicity of, look at the power, 2. This is a bouncer or a tangent. So it's 0, it's going to bounce. How about x minus 4? What's our 0 there? 4. Multiplicity, what's its power if there isn't a power there? 1. That's going to be a crosser. That's going to cross. Last set of parentheses. What's our 0? Negative 2. Multiplicity, that's a crosser. Well, let's get this stuff on here. So we've got 0, 4, and negative 2. Well, we have much more than that. We know the n behavior. That's an x to the 4th. X to the 4th is a parabola that opens up. We also know that it bounces at 0. So this is going to be a bounce. It's supposed to cross at the other two. So it's got to come across, but then it's got to bounce, and then it's got to go back down so it can cross over here. So anything that I know for absolute certain, I'm going to solid. This is solid, and this is solid. The rest of it we have to use the graphing calculator. We have to do our little mins down there in order to get those. But that's what I want for now, is everything we can find without the graphing calculator. We'll put the graphing calculator back in tomorrow. And I know it's been a long stretch, but can we get one more in? Can we get one more in? Yes, we can. All right, f of x equals, and I apologize for that, but I had to get your tests back, just in case anybody is eligible for that retake. Had to do that. Anything we can take out all of them this time? X. Okay, that just might be a perfect square trinomial. Let's check it out. This is x squared, and this is 2 squared, and if you multiply those and double them, hey, you're going to get 4x. Cool. So it'll be x, and then it'll be x minus 2 squared. Well, that's going to help us out with our bouncing and crossing business, too. All right, this x out in front, what's the 0? Yeah, 0. It has to be 0. Multiplicity of? 1, yeah, because it's x to the first. All right, how about the parentheses? What's our 0? 2. Multiplicity of? 2. One of them's a bouncer. Which one is it? The 2. This is even, so this is a bouncer. This is a cross. So we have 0 and 2. But we have more because this was a cubic and it was positive. So end behavior here and here. And now let's put in the part that we can get from this, and that is at 0, it's definitely going to cross, but at 2, it's definitely going to bounce. So it'll come up and it'll come down, and that can be solid right there because I know that's going to be a bounce. But that little dashed piece, that's where we do our local maximum, like we did yesterday. But I'm not going to put that in there today because we're going to talk about that. There we are with our bouncing and our crossing. So for this part of the objective, which is, do you understand when something's going to bounce or when something's going to cross? We're treating 1, 0. You know the difference between the bouncing and the crossing. All right, so always check the powers again. That's going to tell you. And I am changing the assignment, so don't write down any of the blah, blah, blah that's up here. So that we are only working on the stuff that we covered today. We're going to do Section 5.2, Day 2, page 293, 19 to 34, 52 to 54, 58, and then, because there aren't any good examples in your book, remember when we did the write the polynomial function of least degree, blah, 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 blah. So I'm going to put write, blah, 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 for 2i and the square root of 3, and 3i and the square root of 5. So there'll be 2 problems that are not in your book that you're going to write polynomials for. Write a polynomial function in standard form with the zeros, 2i square root of 3. And then the next problem will be 3i square root of 5. Let me move that up. Looks like they're 2 loafers.